So, what's the price of a clean river? Or what's the real cost of a stable climate? For a long time, our economy basically treated these things as if they were free. In this explainer, we're going to dive into the really fascinating field of environmental economics. It's all about trying to make these invisible environmental values, well, visible, so we can finally start to properly manage the relationship between our economy and the natural world.
Okay, so let's jump right in with a huge question. If free markets are supposed to be so efficient, why don't they seem to protect the environment on their own? I mean, it's a real puzzle, right? And it gets to the very heart of why this field of economics even exists. It really sets up the core problem we're about to unpack. Well, the answer really lies in what economists call the market's blind spot. There's this fundamental concept that explains why the price you pay for something often doesn't reflect its true environmental cost. And it's a really powerful idea called an externality.
At its core, an externality is just a side effect. Think of it as an economic impact. Could be good, could be bad, from some activity that affects someone who wasn't even part of the original deal. And here's the crucial part. It's a cost or a benefit that isn't reflected in the price tag.
Let's make this super concrete. Imagine a factory making, widgets. To keep costs down, it just dumps its waste into a local river. Now, the cost of that pollution, to the fishermen downstream, to the town that has to pay to clean its drinking water, to the health of the whole ecosystem, none of that is included in the price you pay for the widget. That hidden cost, that's a classic negative externality.
So if the problem is that nature's services don't have a price, the logical next step for an economist is, okay, let's figure out what their price should be. But how on earth do you put a dollar value on something like a clean river or a pristine forest?
One of the main ideas economists use is something called willingness to pay. It's actually a surprisingly simple concept when you break it down. The value of something like clean air can be estimated by what we, as a society, are willing to pay to have it, even if we don't use it in the way we'd use a product.
So how do they actually measure that willingness? Well, one common tool is the contingent valuation method. It's basically a really highly structured survey. Researchers describe a realistic, hypothetical situation, like a policy to clean up that river we talked about. Then they ask people what they'd be willing to pay, say in higher taxes, to make it happen. You analyze thousands of these responses, and you can start to build a data-driven estimate of that non-market value. But let's be real, this is far from simple. As this quote gets at, the methods for valuing nature can get so complex, so focused on academic details, that they actually become hard to use for real-world policy. It really highlights a huge challenge in the field. How do you get a number that's not only accurate, but also useful? Okay, so even if the numbers are imperfect, we don't have to be stuck. Economists have developed this pretty powerful toolkit to start fixing these externalities, offering a whole set of practical solutions.
These tools usually fall into two main camps, and they each have a different philosophy. The first one is all about pricing the problem. The idea here is to force polluters to internalize that externality, basically make them pay for the damage they cause. A carbon tax is a perfect example. The second approach is about creating new markets. With this, you set a firm limit, a cap, on total pollution, and then you let companies buy and sell permits to pollute. The goal here is to let the market find the cheapest, most efficient way to stay under that cap.
Let's take that pricing approach. So when you get in your car, you don't pay for the time that other drivers lose because you're adding to traffic, right? Well, when economists actually calculate the cost of just that one externality, traffic congestion, they estimate it adds up to about 56 cents per gallon of gasoline in the US. That's a huge hidden cost that our corrective tax could make visible every single time we fill up the tank.
And that market-based approach? It has had some incredible successes. The U.S. Acid Rain program used cap and trade to cut sulfur dioxide emissions, and you can see the results right here. I mean, wow. That steep drop in emissions didn't just meet the target, it went way below it, and it did this at a much lower cost than anyone predicted. Why? Because giving companies the flexibility to trade permits created this powerful financial incentive to find cheaper and better ways to cut pollution. It unleashed innovation that regulators never could have seen coming. And the toolkit is just incredibly diverse. Economists have designed all sorts of clever mechanisms. Some are simple things we see every day, like the deposit refund systems for bottles. Others are more complex, like something called mitigation banking, where developers who destroy a wetland in one spot can pay to restore or protect one somewhere else. It literally creates a market for conservation. There are even direct payments to landowners for providing ecosystem services, like keeping a forest healthy so that it provides clean water downstream.
All right, now let's tackle a really special kind of problem. What happens when a resource doesn't really belong to anyone? I mean, who owns the fish in the sea? Who owns the clean air in our atmosphere? This is the unique challenge of what's called governing the commons.
The official term for this is a common pool resource. It's any resource that's open to lots of different users. And the problem is, since no one person owns it, every single person has an incentive to take as much as they can before somebody else does. This can lead to the famous tragedy of the commons, where that shared resource just gets totally depleted or destroyed.
Now, solving this isn't just about the resource itself. To govern the commons effectively, you really have to analyze the whole system. You have to look at the resource, the community of users, and, this is crucial, the rules, both formal and informal, that shape how they all interact.
And this doesn't always require some big top-down government solution. Take fishery cooperatives. In these, groups of fishers can actually organize to manage the resource themselves. They coordinate their fishing times, they adopt their own gear restrictions, they enforce their own rules, and they even chip in to support scientific research. It's a powerful community-based solution that has proven to be highly effective in many places.
So we have the theory, we have the tools. It all sounds great, right? But applying them in the real world, well, it's never as clean or as simple as it sounds in a textbook. These policies are definitely not magic bullets. They face some very real, very tricky complications.
One of the absolute biggest challenges for climate policy is something called carbon leakage. So imagine one country puts a strong tax on carbon. What do you think might happen? Well, energy-intensive industries like steel or cement manufacturing could just pack up and move their factories to a country with no carbon tax. The pollution doesn't go away, it just leaks from one place to another.
And this is not a small problem. The scale of this leakage can be pretty significant. Some estimates suggest that for every 100 tons of emissions a country cuts through a domestic policy, somewhere between 15 and 25 of those tons could just reappear somewhere else. That offsets a huge chunk of the progress you thought you were making.
The real world is also just messy. Look at this chart of pesticide use over time. It's not some smooth, predictable line. It's full of jagged spikes and dips. And that's because policy, technology, weather, and just plain old human behavior all interact in these really complex and sometimes surprising ways. A simple rule almost never produces a simple linear outcome. And finally, of course, there's the human element. Politics and people. International agreements are often described as a two-level game. A country's leader has to go negotiate a deal with other countries, but then they have to come home and get that same deal approved by their voters and politicians. So what might be the most economically efficient solution on paper might just be politically impossible in the real world.
So what's the big takeaway here? Environmental economics is not about finding one perfect magical solution. It's about building a dashboard, a whole collection of different tools for different situations. But the ultimate goal is always the same: to make the hidden environmental costs of our economic choices visible so that we can finally start accounting for them when we make decisions.
Which really leaves us with the ultimate question for our time. By making the invisible visible, can we finally design an economy that sees the full picture, one that truly values both our prosperity and the planet that makes it all possible?